In functional programming, you're very strongly encouraged to use what's called pure functions. And these are functions whose output depends entirely on their input parameters. They're not allowed to cause any side effects at all, including accessing or modifying global state, or even changing the parameters that were passed in. Those parameters must be immutable. All a pure function is allowed to do is return some more data. Now, this can seem extremely limiting at first, but programming in this style brings a lot of benefits, such as making our code inherently thread safe, making unit testing much easier, and also it makes your code easier to reason about, which all leads to fewer bugs. Now, you might think that LINQ doesn't really do anything special to encourage this style of programming with immutable data. But actually, when you think about it, when you construct a LINQ pipeline, the output of each stage is a new sequence of data rather than the original collection or sequence of data being modified. So for example, if I say mylist.where and I say just give me the values that are greater than 50, I've not actually changed the contents of my list at all. It remains unchanged. And also, when we use anonymous objects, which we've used many times in this course, they're also immutable. You can't actually change their values after you've set them up. And so in the Lambda expressions that we pass into our LINQ select calls, we're actually very strongly encouraged to return new objects rather than just modifying the object that we were given. Now, of course, it's true, side effects are inevitable in programming. After all, output to disk or screen or the network is a side effect. But functional programming encourages us to minimize and isolate these side effects so that the bulk of our code is created with pure functions and all of that important business logic and domain-specific rules are contained within those functions. And of course, this has the great benefit of making it much easier to unit test those business rules. So the next time you create an object in C#, why don't you think about whether you can make it immutable? And the next time you're creating a new method, why not see if you can make it a pure function whose output relies solely on its inputs and will always provide the same output when given the same input? You might be surprised at how much this improves your code.